This sample problem is on spring force or Hooke's law. The student plots a graph of load against extension as shown in the figure below. So we have load on the y-axis, or this actually represents the force of the spring, and we have here the extension or the delta x. Now remember that Hooke's law states that the force of a spring, or FH, is equal to the negative of the spring constant times k. The negative sign that we have here simply tells us that the spring force is a restoring force. So if the load is directed to the left, then your spring force is directed to the right. It will be in the opposite direction, but of the same magnitude. So for example, if our load is, say, 1 Newton, that means to say that the spring force is also equal to 1 Newton, but in the opposite direction. So since we would only be dealing with magnitude, then we could just remove this negative sign here, so that we will use the equation the spring force, or FH, or the Hooke's law force, is equal to K times X, where K is your spring constant and X is the extension. So let me just label that. So the first question, determine the extension produced by a load of 7.5 newtons. Now we could actually get that information from the graph. So if we have 7.5 newtons, meaning to say it is at this somewhere here, it's in the middle. So 7.5 newtons will be somewhere here. That is 7.5 Newton. Then we could trace it on the graph. Like so. But we know that it's going to be somewhere between 28 centimeters and 32 centimeters. So in order for us to obtain the exact value, what we're going to do is to use this equation right here to solve for x, because this x is actually constant, and that is the slope of this graph here. So let's solve for x by looking at values that we are so sure, by looking at values that we could obtain from the graph. For example, we could use this value right here. So when the load is equal to 2 newtons, so this is our FH, we have an extension of 8 centimeters. So let's try that out to solve for K. So when the load is 20.0 newtons, our extension is equal to 8 centimeters. So we could use that to solve for K. So extension is 8 centimeters. So then we will have our K is equal to 0.25 Newton per centimeter. So we are going to use this K in order for us to be able to solve for letter A, which is the extension when the load is 7.5 newtons. And then we could also use the same value for K to determine the load when the extension is 10 centimeters. So let's solve the problem now. So we have FH is equal to KX. So when we want to know the extension, when the load is 7.5 newtons, therefore, we will have our load, which is our FH. So this is going to be 7.5 newtons. The K is 0.25 as what we have previously obtained. And then we could solve for the extension. This means that our x, or the extension, is equal to 30, and the unit is centimeters, because this is the unit that is given on the graph. So the extension is in centimeters. Now for part B, determine the load that would produce an extension of 10 centimeters. So again, we could still use the same equation. We'll have FH is equal to KX. Now we want to know the load that would produce an extension of 10 centimeters. So we'll have FH, that's what we need to solve for, is equal to the K, which is 0.25, multiplied by the extension of 10.0 centimeters. Plug these values in your calculator. We'll get FH is equal to 0.25 times 10. That will give us 2.5 newtons. And now for part C, let us write our solution. This part here, calculate the mass that has a weight of 6 newtons. So remember that weight is just equal to mg. So if the weight of the object is 6 newtons, that is equal to the mass is what we need to solve for, multiplied by g, which is 9.8 meters per second square. So therefore the mass of the object would be 6 divided by 9.8, 0.61 kilogram, or approximately equal to 0.6 kilograms. And that concludes this tutorial. I hope you learned something.